Okay, today we'll discuss with the topic of the numerical method. Okay, this is the second module in advanced mathematics. Okay, in the advanced mathematics numerical method, in that we have two different formulas, that is the Newton's forward interpolation formula and Newton backward interpolation formula. Okay, these two formulas we are using to find the value of x. Okay, to find the value of x we are using this formula. Here the value of y is equal to the f of x at x is equal to the x naught plus rh. Okay, this is the function. Y is equal to f of x is a function. Okay, then at x is equal to the x naught plus rh. X naught is the initial value plus r is the real number, h is the equal interval. Okay, so by using this, okay, after adding all these terms we can get the next term of the series now. Okay, is 1. Okay, to this one if you are applying r into h equal interval and the real number, we can get the next value. Okay, so from this we are separating r, so r is equal to the x1 minus x naught divided by h will come. Okay, then yr is equal to the y naught plus r into the delta y naught plus r into the r minus 1 by 2 factorial into the delta square y naught plus r into the r minus 1 r minus 2 divided by 3 factorial into the delta cube y naught plus so on is the formula of the Newton forward interpolation formula. Okay, where r is any real number. Okay, what all the r will come in the formula? No, that is nothing but the real number. Okay, then in the Newton's backward interpolation formula, the value of the y is equal to the f of x at x is equal to xn plus r plus h. Okay, here we are taking the expression as xn plus r plus h. In this forward, x naught plus r into h will take. Okay, again we are separating the value of r from this, so r is equal to the x minus xn divided by h will come. Okay, then the standard formula of the Newton's backward interpolation formula is yr is equal to the yn plus r into the delta yn. Downward delta we are using in the backward, then upward delta we are using in a forward interpolation formula. So plus r into the r plus 1 by 2 factorial delta square yn plus r into the r plus 1 r plus 2 by 3 factorial into the delta cube yn plus so on, where r is any real number it is. Okay, now we'll solve one problem on this. Here one thing, interpolation and extrapolation. Here they given the name as interpolation, right? What is interpolation? What is the meaning of that interpolation? Means if we are finding the value of x within the given range. Okay, for example this 1 to 5 is there. Within the 1 to 5, if you want to find the value of x, so to that we can see the interpolation. If you want to find the value of x outside the range, outside the 1.1 and 5, means 5.5 or 0.2, okay, 0.2 and 5.5 and more than 5 less than 1 number are all the extrapolations. Okay, if you want to find the value of x outside the given range is called that as a extrapolation. Okay, now let us solve one problem on this. Find the y of the 1.4 given that x values are 1 2 3 4 5 and y values 10 26 38 112 and 198 it is. Okay, these values we have to apply it in a table of the Newton forward interpolation. Okay, difference table, to this we can call it as a difference table. Okay, then x values write in a column 1 2 3 4 5 so on, and y is 10 26 58 112 and 198. Okay, now we are finding the first difference, delta y. Delta y is 26 minus 10 is a 16, 58 minus 26 is 32, 112 minus 58 is 54, 194 minus 112 is 82. Similarly, 32 minus 16 is 16, 54 minus 32 is 22, 82 minus 54 is 28. Similarly, 22 minus 16 is 6, 28 minus 22 is 6, 6 minus 6 is 0. So like that we are finding the difference of the numbers. Okay, the first difference is delta y, second difference is delta square y, third difference is delta cube y, fourth difference is delta raised to 4y it is. Okay, now in the forward, if you want to apply the forward interpolation, here they will not give use forward difference or backward difference. Okay, by seeing this value, x value, we have to choose the appropriate formula. Okay, so 1.4 is there. This 1.4 is very close to the first initial value. Okay, 1.4 is very near to 1, so we have to apply the Newton forward interpolation formula. If the given value is a 4.5, okay, if it is 4.5, then we have to apply the Newton backward. Okay, that 4.5 is near to the last entry is 5. Okay, so that in that cases we are using the Newton backward interpolation formula then. Okay, as we know the Newton forward interpolation formula, that is yr is equal to the y naught plus r delta y naught plus r minus 1 by 2 factorial into delta square y naught plus so on. Okay, this is the formula. In that, we are using the first entries of each column in the forward interpolation. Okay, if you want to apply the backward interpolation, we are using the last entries of each column in the formula there. Okay, then here y naught is nothing but this given value, delta y naught is nothing but this first difference, delta square y naught is second difference, then next delta cube y naught like this will come is the third difference, first entry of the third differences. Okay, then r value, to find the r value we are using this expression r into the x minus x naught divided by h. Okay, h is an equal interval means 1, the difference between the value of x is 1 only. Okay, these two formulas we are using only for the equal intervals. Okay, if the x value is equal interval, then only we can apply the forward or the backward interpolation formula. Okay, then continue this. Then r is equal to x minus x naught by h formula we are using. So r is equal to the x is nothing but the given value is 1.4, x naught is 1 initial value, then h is the difference between the x value is 1. Apply it, simplify it, finally we will get the value of h as r as of 0.4. That 0.4 we are using it in the Newton forward. Wherever you have r no, replace it by 0.4 and the difference. So 10 plus 0.4 by 16, 4 into 16 by 1 factorial, plus 0.4 into the 0.4 minus 1 by 2 factorial into 16, plus 0.4 into 0.4 minus 1, 0.4 minus 2 by 3 factorial into 6. Okay, then after simplifying all this, we can get the answer it as the 14.864 it is. Okay, just expand this, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. Okay, then divide it. Okay, after simplification, finally we'll get the 14.864 as the answer. Okay, so this is the value of the 1.4, y of 1.4 it is. Okay, then let us take one more problem on this. Find the u of the 0.5 from the data u0 is equal to the 225, u1 is equal to 238, u2 is equal to 320, u3 is equal to 340. Okay, x values, right, which are 0, 1, 2 and 3. Y values are 225, 238, 320 and 340. Okay, then you just find the value of h. H is, what is h now? H is equal to the equal interval 0, 1, 2, 3. Okay, the difference between all this value is 1 only, so write it as the 1. Then apply it in the difference table. X is equal to 0, 1, 2, 3, y is equal to 225, 238, 320, 340. Then subtract this. After subtraction, we get the difference of this number, that is 13, 82, 20. 238 minus 20, 225 is 13, 320 minus 238 is 82, 340 minus 320 is 20. Then 82 minus 13 is 69, 20 minus 82 is minus 62, minus 62 minus 69 is minus 131 it is. Okay, here we have to find the value of the 0.5. This 0.5 is very close to, wait, is very close to 0 now. 0.5 in between 0 and 1 will come, that value is very close to 0, so we have to apply the Newton forward interpolation formula. What is that formula? Is yr is equal to the y naught plus r delta y naught by 1 factorial plus r minus 1 by 2 factorial into delta square y naught plus and so on. Okay, so the r is equal to the x minus x naught divided by h is equal to the x value is the 0.5 minus the x naught is a 0 divided by HL is 1. Okay, so 0.5 minus 0 divided by 1. So this r is equal to the 0.5. This value we have to apply. R value we are applying it in the Newton forward interpolation formula. So this y naught is means the initial values. Okay, first enter of each column we are applying 225. Okay, x naught value is 225 plus y naught value is 225 plus r value is 0.5, delta y naught is 13 by 1 factorial plus 0.5 into the 0.5 minus 1 r minus 1, 0.5 minus 1 by 2 factorial into the delta square y naught is 69 plus 0.5 minus 1 by 3 factorial into the 0.5 minus 2, next term is okay, then delta cube y naught, that is minus 131. Then you just simplify all these numbers, is 214.6875. okay, so finally we can say u of 0.5 is equal to 214.6875. okay, like this we have to solve the problems on the Newton forward interpolation and the backward interpolation formula. Okay, let me take one more problem on this. The area of a circle A corresponding to the diameter B D is given below. D is 80, 85, 90, 95, 100. A value is 5026, 5674, 6362, 7088, 7854. Find the area corresponding to the diameter 105, okay, using an approximate interpolation formula. Okay, they didn't even use interpolation or backward or forward interpolation. Okay, so that the x value says the meaning of this is if the diameter is increases, the area of the circle is also increases. Okay, so now 105 is there. 105 means outside this range will come. 80 to 100 is the range, but 105 is the outside the given range. So to that we can call it as a extrapolation. Okay, to that also the same procedure, creating a table and all. So x value, d diameter considered as a x, area considered as a y. Okay, so the d values are 80, 85, 90, 95, 100. Y values are 5026, 5674, 6352, 7088, 7854. Then find the difference of this all. The difference of this is 648, 688, 6726, 666. Then again find the difference of this is 40, 38, 40 will. Again find the difference of this minus 2, 2 will come. Again find the difference of these two, that is plus 4. Okay, so write in between that numbers. Okay, then that 105 is very close to 100 now. Okay, so that we are using the Newton backward interpolation formula, NBIF, Newton backward interpolation formula. That is yr is equal to the yn plus r into the delta yn plus rr plus 1 by 2 factorial delta square yn plus rr plus 1 r plus 2 by 3 factorial delta cube yn and so on. So the r is equal to the, to find the value of r in the backward interpolation, x minus xn by h we are using. So r is equal to the x is 105 minus xn is 100, last entry. Okay, xn is 100 divided by h is equal interval is 5. After simplification we'll get r as a 1. So r is equal to 1 here. This r value is 1. We are applying it in the Newton backward interpolation. The yn. Okay, here in the backward interpolation we are using the last entries of each column. Okay, so that the yn is the last entry is a 7854 plus r is 1, delta yn is 766 plus 1 plus 1 is 2 plus the delta square yn is 40, okay, divided by 2 factorial plus 1 plus 2 plus 3 r plus 1 r plus 2 by 3 factorial into the delta cube yn is 2 plus 1 2 3 4 into the last entry is of 4 divided by the 4 factorial. Now just simplify this all, okay, by expanding the factorization and all. Okay, we'll say just simplify it we'll get the answer as f of 105 is equal to the 8666. Then the area of the area A corresponding to the diameter D is equal to 105 is 8666. Okay, is it clear?